In the following video, we're going to talk about analyzing arguments. So now we're on to the third section of chapter 1. We've talked about logical fallacies, and we've talked about Venn diagrams. Now we're going to fuse the two together in a way so that we can create a third section that allows us to more analytically look at the way that people build arguments to see whether or not they make sense. So we're going to use that Venn diagram. We're going to use what we know about logic so far, and then we can find a more objective way of analyzing these things. So we have three objectives. The first one is we're going to learn about the two types of reasoning, inductive and deductive reasoning. And then we're also going to construct Venn diagrams to analyze an argument. So this is kind of what we talked about at the very end of the last section in Venn diagrams when we were constructing categorical propositions. We're going to do something really similar in order to analyze arguments. They're going to give us some sort of a statement, and we're going to build a Venn diagram that represents that statement. And then we can go on to see whether or not that statement is valid or sound. We'll talk about what those two terms mean in just a moment. First, let's talk about inductive and deductive reasoning. So inductive reasoning is kind of like how my daughter sees the world. She observes a lot of specific things, and then based on all of those observations, she makes some sort of general conclusion. So this is a really good one. We have a couple premises here. Bluebirds fly, hummingbirds fly, cardinals fly. And so you can imagine seeing all these different birds fly, then you come to this conclusion that all birds fly, right? Unfortunately, the problem with inductive reasoning is that with inductive reasoning, it only takes one specific example in order to prove something false. And so you can find all of these examples in the world about how something is true. You can find tons and tons of specific instances of birds that fly, right? And if your whole life, all you see are flying birds, then you can make that conclusion. But someone could shatter your whole paradigm if they just say, hey, look, here's an ostrich right here, and this ostrich doesn't fly. And now the entire conclusion that you've built is completely broken now, right? So it only takes one case to prove inductive reasoning wrong. And so that's why it has this flaw to it. But naturally, it's how we observe the world, particularly when we're really little. Then we go on to deductive reasoning. So deductive reasoning kind of does the opposite. The deductive reasoning takes a lot of general ideas out there. It makes connections between those general ideas. And because of those connections, we're able to get a really specific conclusion. Now, this reasoning is much more sound, and it's what we use in analyzing arguments. And so here we have an example. The first premise is all doctors are intelligent. The second is that Dr. Oz is a doctor. And so if all doctors are intelligent and Dr. Oz is one of those doctors, then the conclusion can be that Dr. Oz is intelligent. Yeah, he doesn't look so convinced right there. So this is an example of a deductive reasoning and an argument that's built that would be, I would say, valid, but not necessarily sound. We're going to talk about those two things right now. So inductive arguments, like I mentioned, they don't really prove their conclusion true. So they're just evaluated based on their strength, right? If you have lots and lots of information and lots of examples in your inductive one, remember we're talking about the birds now, the more examples you have, the stronger of a case you can build, right? Doesn't necessarily mean that you can convince somebody based on all of those examples, because like I said, it only takes one to destroy it. But you can say that something is strong if you're giving a lot of compelling evidence for that reason, right? And of course, you could say then the opposite, an argument is weak if the evidence isn't really supporting the conclusion very well. So now we want to talk about how to evaluate deductive arguments. And so there are two different criteria that we use to evaluate a deductive argument. An argument can be valid if the conclusions follow from the premise. So if it's a nice flow that makes sense logically, then we could say that that argument is valid. And we're going to talk about more things in validity here in a minute. When we build Venn diagrams, the Venn diagram will kind of allow us to make the decision whether something is valid or not, just basically on the picture. We know how to label everything. And then there's this extra criteria for deductive arguments about soundness. An argument is sound if it is valid and all the premises are true. So I'm actually going to go back to Dr. Oz for a second. So in this example, this conclusion does follow directly from these premises. So this would be an example of a valid argument. But you could argue also the first premise, that all doctors are intelligent, is not necessarily true. You could probably give me an example of a doctor that you may know or heard of who's not really intelligent, Dr. Ross. And based on that, then you can say, well, this is valid, but the premises aren't necessarily true. And so that this would be a not sound argument. So things can follow logically, and we call that valid. But if the premises don't make sense, if they're not true all the time, then we can't necessarily say that it is sound. One more thing about valid and sound before we go into some examples. Really important here, an argument is sound if it is valid. So the first thing that we do when we evaluate arguments is we test for validity. If it is valid, then we go on to the second sentence about, well, is it sound or not? And then we can answer that question. But if in the very beginning we draw the argument out and we find out, oh, this isn't valid, we don't even need to go and discuss the idea of soundness. Soundness can only happen if an argument is valid. So as soon as it's not valid, we don't even have to go on any further. We can say, oh, it's not valid, which means it's also not sound. So here's the test that we're going to use to discuss whether an argument is valid. The first thing we're going to do is we're going to draw a Venn diagram that represents all of the information that's contained. These Venn diagrams will always be subset Venn diagrams, so one circle inside of another circle. We'll label all of that information based on those premises. Then we're going to have another piece of information that we're going to label in the Venn diagram with an X. And if that X fits in a place that's supported by the conclusion, then we say the argument is valid. If the X is not in a place that's supported by the conclusion, then we say it's not valid. So it's a whole lot easier when you see examples. So let's do some. This first one says, construct a Venn diagram to test the validity of the deductive argument. We're going to use the letter X to represent whales. So we're going to first look at this first premise here that says all fish live in water. Now there are other things that live in water other than fish, but if you're a fish, you live in the water. And so that allows us to label our Venn diagram. If all fish live in water, then my inner set is going to be fish. And my outer set is going to be things that live in water. Sorry, my handwriting's terrible. So now we've taken care of this first premise. All fish live in water. Good, we're done with that. We labeled fish. We labeled things that live in water. And now we're going to use this in order to find out where we're going to place our X. It says whales are not fish, which means our X is not going to go in this, our X is not going to go in this inner circle right here. It said whales are not fish, so our X can't go here. But this premise did not say anything about whether or not whales live in water. Now, naturally, we know whales live in water, but that's not the point here. It has to come from the premises in order for the argument to be valid. So in here, it told us whales are not fish. So we know we're not in this circle, but we can't say whether or not we're in this outer circle. So the place that we're going to put our X is going to be right here on the edge of this circle, because we don't know whether or not whales live in water or don't live in water based on these first two premises. The conclusion says whales do not live in the water. Our X is not inside of the water and is not outside of the water region. And so we're not really sure where the whales live. This tells us that the X is not being supported by this conclusion. Therefore, this argument is not valid. We'll do some more examples of this. And if you like, you can always come back and check these out. Oops. I'm sorry. The next example says, if a person lives in Chicago, then the person likes windy days. So let's start by drawing our Venn diagram on the first premise. A person lives in Chicago, then the person likes windy days. You don't necessarily have to live in Chicago to like windy days. You could live in some other city and like windy days as well. But this is saying that every person that lives in Chicago likes windy days. So I'm going to put Chicago here. So you live in Chi-Town, you go here. And if you like wind or like windy days, if you want to be more specific, then you're on the outside. So again, this Venn diagram is telling us everybody that lives in Chicago likes the wind. Now, the next part says, Carlos lives in Chicago. And again, in this example, we're using the letter X to represent Carlos. And so it says Carlos lives in Chicago. So our X is going to go clearly inside of the Chicago circle. Now we check the conclusion. The conclusion says Carlos likes windy days. In this case, the X is in Chicago. It's also inside of the people that like wind. And so it is supported. We are happy here. So this is an example of a valid argument. We'll do a third example. Our last example says, a narcotic is habit forming. Aspirin is not habit forming. Therefore, aspirin is not a narcotic. So this first premise says a narcotic is habit forming, or in other words, all narcotics are habit forming. So our narcotic is going to go on the inside. Maybe there are other things that are habit forming, like playing too many video games. And so that's another way of looking at it. I feel like the biggest problem or the most difficult thing that students have with this section is figuring out how to label the interior region and the exterior region, or these two circles right here. And so ask yourself, are all of this group part of this group, or can I come up with examples where that isn't necessarily true? And that'll help you figure out the direction, or which one is the inner group and which one is the outer group. And so in here, all narcotics are habit forming. So narcotic is going to go in the inside, habit forming on the outside. Then it says aspirin, which is what we're going to use our letter X to represent, is not habit forming. So again, habit forming is the big circle here. It says that aspirin is not habit forming, which means our X to represent aspirin is going to go on the outside of the big circle. I'm going to put it right here. So we took care of the first one, we took care of the second one, and now we want to see, is the conclusion supported in our picture? So the conclusion says aspirin is not a narcotic. Remember, X represents aspirin. The X is here. It is not in the narcotic circle, so we're good. Once again, we have a valid argument. So again, your X is going to be what you're labeling. I will always tell you what to label the X, what set is being labeled with X, in this case, aspirin. And so we take these two premises. That allows us to first label the Venn diagram. The second premise allows us to draw the location of our X. And then lastly, we look at the conclusion and we see, does it make sense? Does it fit the picture that we have? If so, we have a valid argument. For soundness, soundness has a good level of subjectivity. One person might say, oh, this statement doesn't make any sense. And another person might say, oh, no, that statement makes sense. And they could sit and argue about it all day long. And so that's where the idea of soundness is kind of subjective. It's kind of, it has some opinion to it depending on what the premises are. So I'm really far more concerned with you being able to tell me if argument is valid. That validity is something very objective. We can draw out the places in the Venn diagram. We can place our X, and basically it tells us whether or not we're looking at a valid argument or not. So when you're doing your homework, it may ask you a lot about soundness, but just keep in mind that for your exam, for high stakes stuff, the most important thing is being able to test whether it's valid. Thanks a bunch. Please reach out to me if you have any questions.